Hello guys, let's talk more about the ideal gas equation, specifically about the molar volume. So what is it? It is the volume occupied by 1 mole of a gas at standard temperature and pressure, which is also called STP. So what is it? Standard temperature is 0 degrees of Celsius or 273.15 degrees of Kelvin, and the standard pressure is 1 atm, which equals to 760 torrs or 1001.325 kilopascals. Now, let's talk a little bit about pressure. So the pressure at sea level equals to 1 atm or 1 atmosphere. And when you think about the atmospheric pressure, it is just simply the pressure within the atmosphere of the Earth. We literally live in a huge ocean of gas, and you can feel it if you just, with the wind, or if you just do this with your hands. So think about it. It's basically we have a bunch of teeny tiny molecules zooming all around above us in the Earth's atmosphere. Where will you have the highest pressure? On the bottom or on the top? Just think of a ball pit. What if you are just trying to swim in it?
Bazinga. Bazinga.
As you go lower and lower, you are going to have more and more and more of these balls on top, right? So the pressure is going to get higher and higher as you go lower and lower. So from here, we can actually know that the pressure at lower levels, so let's say at sea level, is going to be higher than compared to the pressure on the top of the mountains, right? Let's say here in Reno, we have a lower atmospheric pressure than compared the pressure at San Francisco next to the ocean. Okay, I hope this makes sense. So the pressure at sea level is 1 atm. As you go up to the mountains, that decreases, but when you go down to, let's say, Death Valley, it's going to increase because we are going to have more and more molecules above us in the Earth's atmosphere. So now, let's try to calculate the molar volume at STP for an ideal gas in liters. So first of all, we have to take the ideal gas equation and solve for the volume. So from here, the volume equals nRT divided by P. So because this is the molar volume, we are going to have 1 mole of the ideal gas. So I'm going to add 1 mole here. And then I have to multiply it by the volume of R. Which one to use? Well, you can use, let's say, the one with ATMs if you use the pressure as 1 ATM, or you can use the one in torrs if you use the pressure in torrs, and so forth. So let's use the one in ATMs, okay? So it's going to be 0.0821 liter ATM divided by a mole Kelvin. And then we know that when we are talking about the pressure, we will have to use the pressure also in 1 atm. So I'm going to add that right in here. And don't forget about the temperature T. So it is 273.15 kelvins at STP. And if you do this calculation, you are going to get 22.4 liters. And that is actually the molar volume of an ideal gas at standard temperature and pressure. All right, I hope this makes sense. See you in the next video.